Anytime.
Good afternoon, everyone. I'm Indu Maria Jos, representing our group Synergy. First of all, let me introduce my group members: Janvi Patel, Jitin Matthew, and Ashwati Mohan. So today we are here to discuss about our project, that is the biodiesel synthesized from waste cooking oil. So here today we will be discussing about the introduction part, the goals we achieved throughout our project, and the timeline we have taken, and the process we have used, and the result, and also data we have collected, and also the issues, all the challenges we faced during our experiments, and also the further steps or the future steps we are planning to do. So first of all, the introduction part. So first is, what is biodiesel, or why is biodiesel? So what is biodiesel means? It is a renewable source of energy, and it is a biodegradable source of fossil fuel. So why is biodiesel? Because as we all know, the number of vehicles are increasing day by day in our country, and also due to the depletion of world's petroleum reserves and the environmental concern, it is a great demand to introduce a new alternative for the fossil fuels such as the petrol and also diesel. So here we introducing the biodiesel because as I told before, it is a clean renewable source, as it is produced from non-toxic sources such as cooking oil or the animal fat. So basically the biodiesel is a production of a trans-esterification reaction where the glycerides react with alcohol to produce esters and glycerol. And biodiesel is also known as biodegradable because as compared to other fossil fuels such as petrol and the diesel, it is known as a carbon neutral. Why is it called as carbon neutral? Because it produces it doesn't produce any carbon outcomes forms such as carbon monoxide, which is really severe to our environment, which as compared to the petrol, it produces all kind of greenhouse gases such as carbon monoxide, which affect the air pollution and water pollution. So first of all, the goals. Here we produce the biodiesel synthesis from three different methods. We have combined three methods such as strainer method, second is microwave, and the third is electrolysis. And after comparison and produce the biodiesel, we have characterized the each biodiesel by the characterization method, which are FTIR and the gas chromatography, to know the efficiency and the quality of the biodiesel. So the next is the timeline. We have to take about the 12 weeks. The first week we have done the preheating, filtration of the waste cooking oil. The third to 4 weeks we have done the titration, acid value calculation, the rechecking of the trainer method. In the 5 to 7 weeks we have done the trainer method and also the separation of the biodiesel from the glycerol. From 9 to 10 weeks we have done other two methods, that is electrolysis and the microwave method. And the last week we have done the separation characterization method using the FTIR and gas chromatography, and also we have done all the data collection and result discussion, everything in the last week. So the next is the stages of synthesis. The initial stage of the biodiesel synthesis is the waste cooking oil preheating. Why we preheated the waste cooking oil? Because as we know that the waste cooking oil, that is the used one, so it may contain it might have contained the moisture content. So in order to reduce or to eliminate or the removal of the moisture content, we have preheated the waste cooking oil. We have taken about 1 liter of waste cooking oil, preheated about 2 hours in temperature from 50 to 60 degrees Celsius. So the second stage is that the filtration of waste cooking oil. We have filtered the process which took about the half an hour. Here you can see the images how we filtered the waste cooking oil. So the next step will be discussed by Ashwati now. Thank you.
Good afternoon all. Now I will be talking about the other stages. The stages number 3, which is the titration of waste cooking oil. Here we found the it might lead to saponification reactions because the free fatty acid react with the catalyst, that is the NaOH that we have used over here, and form soaps, which will reduce the yield of biodiesel. So we found the free fatty acid content over here by the equation, as you can see on this. And next step is a mode of catalyst. So we determine how much catalyst we need to use for the next steps. So these are the values that we have calculated. From the titration, we calculate the values 1.5, free fatty acid content as 1.06, which is pretty good. And the amount of catalyst, it is found to be 6.5 grams. Finally, moving on to the steps, like the extraction process. The first method is trainer method. So you all will be confused what trainer is. So this is actually the conventional method. We just use a machine named trainer. So as you can see in the picture, this is the trainer machine, which has 3 chambers. One is the preheating chamber, the methoxide mixing vessel, and the main mixing chamber where the trans-esterification process occurs. So once again, we preheat our cooking oil in the preheating chamber, and the catalyst and the methanol that we use is mixed in this chamber. So once a valve is opened, these liquids is transferred into the main mixing chamber, and the trans-esterification process occurs. And the experimental conditions that we use is 60-degree temperature and for 2 hours. So after 2 hours, the trans-esterification process will be done, and we will keep the mixture for resting. So this is actually what happens in the machine. So once after 12 hours, we can see the biodiesel will be separate on the top, and the glycerol, which is a byproduct of the trans-esterification process, will be on the bottom there. Since we had some issues with the machine, we transferred the product directly into a separating funnel. And the next process is the electrolysis. Actually, electrolysis is simply we created an electrolytic solution, and electricity is passed onto it, and the solution gets heated. So we use carbon electrodes, and connections are made, and the voltage we used was 24 volt. So same conditions were used, like 2 hours volt, and we got a yield of 44 ml. The next step is microwave assisted extraction. We used a 35 ml waste cooking oil and methanol 12.25, and the NaOH was 0.275 grams. Since actually I would say this method was failed because we were unaware of some of the steps, and our biodiesel was overcooked, and we got a highly viscous solution. So as you can see, this is the biodiesel separated, and the top layer is biodiesel, and it is the glycerol that we got. This is actually after separation, biodiesel and the glycerol. Now, Janvi will discuss the results.
So hi, my name is Janvi, and I'm going to discuss the result and discussion part of our biodiesel project. So here are some things that we used FTIR and GC for characterization techniques, because this technique shows the functional group that are present in biodiesel in very good manner rather than other techniques which we have been read. So firstly, we have quantified the yield percentage according to the methods which has been done. That is, we have done trainer electrolysis and microwave technique, and the yield which we calculated was like this, that electrolysis gives us the highest amount of yield that has been produced. The yield is biodiesel, and the trainer method shows a little bit lesser than the electrolysis, and microwave technique gives a so low amount of biodiesel. So the best method in terms of quantitative analysis is electrolysis, trainer, and then microwave. Next, please. So yes, this is the spectrum of FTIR. So these are the three different methods through which we have done the analysis of FTIR. First is strainer, the second one is electrolysis, and the third is microwave. So this FTIR method shows that the compound that are present or the functional group that are present in the biodiesel that contains CO group, COC group, C double bond O, or some other CH2, CH3 thing. The flat part, that is the starting part, and that contains the CH2 and CH3 groups, the within the range of 300 to 2500, that shows COC bond group, functional group that are present, and the rest are the other long chain compounds. So you can see with this method we were not actually able to find the components that are present in the FTIR or in our sample is good enough or not, or to check the better quality of the component of function group present in our group, we decided to move on with GC. So can I get results of GC? So here are the chromatograms. The first technique is electrolysis. The first graph is of electrolysis. The second one is, I'm sorry, I can't see clearly. The second one is microwave. The third one is trainer method, and the fourth one is the oil, which we has actually been used as a reference. So we did not have any standards to begin with. So we did the analysis of the peaks which we get manually. How we did it is we did calculate the peaks. Like we calculated, as you can see, the peak is in form of area. So we did calculated it as the area of triangle. Like we have taken the length of the peak and the width from, let's say if the length of the peak is 4 or 8, and the width we have to do it from the middle portion. So it's like if we consider it as 8, the width will be from 4. So whatever we get from this will decide which method is best. So this is the calculation which we have done for the sample trainer. The retention time of the peaks which we have calculated is 11.918, and the area which we got is this, and the percentage area is 46.48.17. For electrolysis, at the same time where we got peak, we got the percentage area of 67.84, and for microwave with the same time, like little bit different but the same time, we got 16.3424. So what we have concluded on the basis of this, with the area percentage, the peak which is very good gives the good quality of the components which are present in biodiesel itself. So electrolysis gives the good peak. So according to that, we concluded or interpreted that the components that are present with the in the biodiesel with the method electrolysis, electrolysis is the best method in terms of yield and in terms of quality. Trainer is the second. We have seen that it gives us product yield and quality same. Microwave, I think that we could have interpreted that the microwave technique was little bit overcooked, and because of these reasons something might have happened with the functional groups that does not gives us proper peak, or that might have degraded the chains of hydrocarbon compounds, and that was the yield and the area percentage of the peaks were low. And I'll just pass on to Jitin.
Hi, I'm going to present the statistical analysis of our result. This is the interval plot, and this is to keep pairwise comparison. According to the interval plot, for electrolysis we got 85% of yield, and for the microwave we got just 52% yield, and for the trainer we got 72.67% of yield. So the best method for the synthesis of biodiesel based on yield is electrolysis. So we faced some issues during our project. The first one was the equipment failure. Our trainer got leaked 2 times, so we lost 2 weeks for that, and we also lost our waste cooking oil. Then the raw material shortage. Because of the equipment failure, we lost 2 liters of waste cooking oil. So we arranged the cooking oil because we need to do all the procedure using same batch of cooking oil. So in addition to that, we did all the procedure again for that. Then the change of plan. In the beginning, for electrolysis, we were planning to use graphite electrode for the electrolysis. We made the graphite electron and conducted the experiment. Unfortunately, we failed on that. Then we used carbon electron for the electrolysis process, and we got a better result. Then the next steps in the future. First of all, we need to do the performance analysis of the biodiesel that we got by these 3 methods. For that, first we have to measure the density and viscosity of the biodiesel. Then we need to find out the heat energy that produced by the combustion of that biodiesel. Then the cetane number. By these techniques, we have to find the performance of that. Then we have to use the different kind of catalysts for that, like heterogeneous, homogeneous, and enzymatic catalyst. And we can figure it out which catalyst will be better for the synthesis of biodiesel.